Alright, introduction to projectile motion. Alright, so what projectile motion is when you throw something through the air. It's like, alright, so I want you to think about what forces might be acting on this while it's flying through the air. Okay, we're going to do a little experiment with this in class today, throwing it. Alright? So let me move the camera up here a little bit closer to the whiteboard so you can see what's going on. Alright? So when we throw that ball through the air, what forces are acting? Alright? So let's say I gave it a shot. Right? And I'll draw a picture of it in a few different locations as it's flying through the air. We'll do it kind of symmetrically. Right? It leaves my hand here, let's say. Alright? Slows down as it gets to the top. Still moving. And speeds up as it comes back down, right? You can see that. So what forces are acting on it? That's the velocity, that's not the force. So below it I'll draw a dot to represent the basketball. We can talk about the forces that might be acting on it. Alright, so there's the basketball there. What forces might be acting on it? Well, definitely the force of gravity, right? As always. We have the force of gravity. Alright, so throughout its motion it's going to have force of gravity. Alright, so again the dot is representing the ball and the force of gravity is pulling it down the whole time. Now, does it have a forward acting force? Well, if you think back, this was a while ago now. No, once it leaves my hand, there's no force pushing it forward. Right? Forces are either coming from direct contact or it's an invisible force due to a field. So from direct contact, it's getting nothing when it's in the air, right? It gets that when I first throw it. When I give it the push, I accelerate from rest up to speed. Yes, it does have a force acting on it. But once it's in the air, the only force that's acting on it is gravity. Now, you might have some air drag, right? Might be a little drag going against the direction of motion here. Right? But most cases, and in this case, we're going to say air drag is negligible. Alright, we're going to say air drag is negligible. So that's it. So as it travels through the air, force of gravity pulls it down. Alright, so it's moving to the side, moving horizontally, while moving vertically. It's actually a combination of two different motions in one. And I have a cool demonstration to show you with this. Might pause that and get that out quick now. While we're kind of in this mode. But we'll see about that in a minute. So let's take a look at one of these force diagrams now and use what we know about Newton's second law to determine the acceleration of the ball. Alright, so our force diagram here is the same. It never changes for the ball while it's in flight. Alright, it stays like this. Even though it's moving, the only force acting is the force of gravity. So that's kind of interesting. Everybody always wants to try to put a force moving it forward, but what would that be? What could that possibly be? Kids will say force of momentum, force of motion. Well, those don't really exist. Remember, forces are always force of one object. Let me grab another marker here really quick. It's always the force of one object, which is the earth, on the ball, right? It's always the force of one object acting on another object. Forces don't just magically appear out of nowhere. Alright, so a force pushing it forward is not really possible because, well, what's pushing it forward? Yes, I did push it forward at one point in time, that's why, you know, it's moving forward and up initially. But after that, gravity takes over, and air drag, right? There's probably should factor in air drag here, but that's a little bit beyond what we're doing. So now instead of Newton's second law, which says F net equals mass times acceleration, all right? Well, what's the net force? It's Fg equals ma. And you plug in the equation for Fg, you get mg equals ma. M's cancel, right? And you get an integral result. You get the fact that the acceleration of the object is simply equal to g. So the acceleration of the ball moving in the air is equal to 9.8 meters per second squared. Now keep in mind this is the magnitude of the acceleration. It's the magnitude of the acceleration. So if I really want to know the acceleration of the ball in terms of positive and negative, I have to come up with a system here. So I'm going to say down is negative here, so I put a coordinate system on this. Right? Positive y, positive x, negative y. I would technically say the acceleration in the y direction is negative 9.8 meters per second squared. The acceleration in the x direction, since there's no force in the x direction, acceleration in the x direction has to be 0 meters per second squared. And that's the important result here. When you throw something through the air, it could be anything. We're going to do in class today is we're going to take the basketball, we're going to throw it at an angle, nice straight line relative to the screen of my phone. And we're also going to throw it straight out, right? Straight out. And an interesting result happens there. I'm not going to give it away now. What we'll see is that it'll accelerate down as it moves forward. All right? It should move forward at a constant rate because the acceleration in the x direction is 0, and it should accelerate down at a constant rate. Now, gotta be careful of saying it that way. It should move forward at a constant velocity, right? Because acceleration and velocity are both rates. So it should move forward at a constant velocity, 0 acceleration, and should fall down at an increasing velocity, a velocity increasing at a constant rate of 9.8 meters per second each second. All right? So that's the introduction of projectile motion. And the big takeaway is, again, when you throw something through the air, it accelerates in the y direction, vertically. There's a force acting on it vertically, which causes it to either speed up or slow down. On the way up, it slows down. On the way back down, it speeds up. But in the x direction, the horizontal direction, because there's no force acting in the horizontal direction, we see there's no acceleration. It's a constant velocity motion. So when we take the video and plot it in Logger Pro, we're going to see two different graphs. We're going to see x velocity and y velocity, and they're going to look different. And x position and y position versus time, and they're going to look different from one another. And we're going to investigate, quantitatively what the accelerations actually come out to be, see if we can explain any of the discrepancies, and so on. Right? I think that's about it for this basic introduction to projectile motion. Worksheet 1 has a lot of background note info on it. Spent a couple days doing the lab. Try to move quickly through the lab. It's not a write-up lab. Actually, that reminds me I need to make some photocopies here before class time. So, sign off here. Talk to you later.